Hey everybody, and welcome back to another video on my channel in this series. So far what we have done is we have looked over our input actions, we looked at setting up calculating max speeds, we looked at doing our gate setups to get our walk, run, sprints. We've done a lot of stuff leading up to this point, and I'm excited to say that we are now going to be diving in the traversal input for the game animation sample project. I've been kind of dozing off on doing this video for a while just because I was really dreading on getting involved in it, but at this point I am actually kind of excited to go right into it. So basically, let me show you what we're going to be working on in this video. So if I bring my other project over, we're going to look up setting up the traversal input that they have here in their game animation sample project, or at least this is my project from what I've copied and researched. And then we're going to look at carving out all of this. But in today's video, we're going to be looking at the top section here where we get our variables set up, because I'm going to show you where we get the console variables and how we do that stuff. So that's what we're going to be working on in today's video, guys. So I am excited for it. So let's go ahead and jump right in and get our jump traversal inputs modified. So let's go ahead and go down to our jump and let's begin our modification. So as far as our jump's concerned, we have our triggered, started, completed, action values, input action, etc. in here. So in doing that, what we need to actually do is we need to move it over to our triggered. So we're going to get rid of the stop jumping because we really don't need it for what we're about to do, because basically we're going to be doing a lot of checks to where it's like after all those checks, then we can jump if, we've met certain criteria. But then it's like, well, when we're not jumping, then we're traversing or we're falling anyway. So, or we're not jumping. So that's pretty much what's going to go on there. So let's go ahead and remove that, and let's add a branch, and we're going to create an action value, or not an action value, a boolean. So at the left hand side, we're going to go into variables, and what we're going to create is doing traversal action. And let me make sure I camel case my stuff just so that way it comes out nicely. And let's go ahead and create a new category for it called traversal. Make sure I spelled that right. Yep. Cool. And then what we're going to do is we're going to leave it as default. We're going to drag it out, and then we're going to attach it to a not boolean. So now, if you recall what we've been doing in the other videos with how the not boolean is working, so basically whatever action or whatever value that we have set for a boolean, whether it's true or false, the not is going to do an inverse of that action. So if we are basically not doing a traversal action, then continue, or if doing traversal action is false, we're going to inverse it to then go out the true path. So go ahead and set that just like that, and then we're going to create another branch, because like I said, we're going to go out the traversal action. So basically, if we're not doing a traversal action, if that is true, we go out here. If we are doing a traversal action, we're just doing nothing. So we're gonna, or if the inverse is equals false, and we just don't do anything. So we need to be true to continue onward. So our next check is we're going to grab our character movement component, and then we're going to do is moving on ground, because we're going to see if we're moving on ground or if we're jumping, falling, any of those kind of actions. And we're going to attach that to our condition just like that. So we got that down. Oop, trying to move this back a little bit. There we go. Now we got our two checks. So if not doing a traversal action equals true, so if we're not doing anything, go forward. And if we're moving on the ground, we're going to check to see if that's true, because if we were not moving on the ground, that means we're falling or we're jumping. So obviously we're not going to want to do anything. So then after that, let's go ahead, and what we're going to do first is we're going to create two functions. So we are going to go here, and we are going to do get traversal, I believe it's forward, forward trace distance, just like that. Give traversal forward trace distance, because what we're trying to do in this one is we're trying to create a pure function that the basic gist of it is we're going to get, you know, how fast our character is going or moving forward, and we're going to use a specific amount of space in front of him to determine whether we're going to jump or we're going to traverse. So like as he's moving forward or in a direction, do we jump or traverse? So here what we're going to do is we're going to grab our character movement, and off of that we're going to get our velocity. And make sure you get the velocity vector, the yellow variable. And then in here, let's go ahead and do get actor rotation. Because what we're trying to do to get our forward vector is, or at least our trace forward, is by getting our velocity. So we need to get our direction in the velocity mixed with our rotation. So wherever we're facing and moving in a specific direction and how fast. So let me go ahead and copy paste my comment for y'all to also copy if y'all want to. So then after that, what we're going to do is we're going to right click and we're going to look for unrotate vector, just like that. And we're going to plug our velocity in and our rotation in. So basically what this is doing is we are using it to transform a vector by inversing the given rotation. So whatever this is, right? So what we're trying to extract the X value. So what we need to do is we need to split the pen, because what we're trying to get the X value, which is our forward movement or our forward rotation, right? So we're using our X value of our velocity to get our ground speed or our forward vector speed, because, you know, our default walk speed is going to be 500 centimeters per second, because that's the default that's set into this third person template. So, and while our left and right strafes are 350 centimeters per second and our backward strafe is 300 centimeters per second, because that's how we set it up with our max speeds when setting up the calculate max speed, right? So here we're just trying to cut off the Y and Z axis movement values, because we only want to get our forward and backward movement, which is our X. So, you know, when I was playtesting this, the vector, you know, when you actually move forward and backward like what we did earlier, it would be 500 forward and negative 350 backward. So that's basically kind of how this is interpreting it. So let me go ahead and copy and paste my comment for y'all to copy as well if y'all want. And I'm going to set pins in here in case I do need to move stuff around, just like that. All right. And now what we're going to do is we're going to clamp our X value. So let's go ahead and get our map range clamp. So basically what we're trying to do here, so similar to how we did it in our, I believe it's calculate max speed, is we're trying to clamp the unrotate vector value that we're getting from the X. So whatever value is being put into here, we're going to clamp it to a certain range. So let me show y'all something. So let me pull over my other project and hit play. So do you see how I have a thing that says unrotate vector in my debugging UI? So while we're not moving, we have an X vector value of 75 due to the clamp, because so far we're at 0, but you'll see when we do a clamp how our input data of 0 and not 500 or anywhere in between is going to be 75. But as soon as we start moving, oh, that's right. My apologies, guys. I forgot that this was kind of messed up, because I've been working in the animation blueprint trying to unravel that mystery for another series that I want to do in regards to it. But regardless, what we're trying to do is, if our value is 0, our outrange is going to be 75. And this is important for the the forward trace vector, because if we're not moving but we're within range of a level block that is traversable, it will check 75 like units in front of it to see if we need to do a traversal action. And then if we are moving, so if we have a velocity going forward on the X value of 500, then we're going to do a trace distance of 350. So if we're not moving, we just get a basic line trace, or like just a normal trace value, and you're going to see in the later portions of the video, or in the other next videos, of how this is working going forward. So I know I put it as an unrotate vector in the debugging, but what it actually is a tracing distance. So like a line trace, or it's a capsule trace is what we're going to be doing with it, or using this for. So that's what it's doing there. So I'm going to go ahead and copy paste my comment into here for y'all to copy if y'all want. And I'm going to change that back. I'm going to prettify my buttons real quick. There we go. And then I'm going to move that up, and I'm going to then do a return node, because we want to return the outranges of our clamp. So yep, return value float, perfect. And then connect that, and then just kind of move it over. So basically that is it for this. Well, one other thing that we do have to do, guys, is we do need to make this a pure function, because we don't want any modifications made in it. We only want specifically what is done in here. So once you do that, go ahead and compile and save. And let me move my calculate max speed into my movement real quick, just to pretty that up real quick, because we're going to do another function for the traversal action. So let's go back into our event graph. And the next thing that we're doing is we're going to drag our pure function out into here. And we're just going to leave it for the moment, because the next thing that we do have to work on, which will be the next several videos in the series, is now working on the traversal action, which is, like I showed y'all earlier, this massive behemoth. However, I'm going to be starting on step 1 of just caching all of the necessary data. So let's go ahead and create a new function, and we're going to call it try traversal action, just like how they have it, right? And then inside, what we're going to do is we are going to then do an input here. So we're gonna list a variable in here, and we're going to make it a float, and we're going to call it traversal forward distance. So this is essentially the input that we're going to be feeding our thing into. So if I compile and save and go back to the event graph, I can bring out the try traversal action, so that way you can see that our input now has this. So we're targeting ourself, or our character, and then what we're doing is the clamp float, so the outrange of 75 and 500 or 300, we're going to then pass in through here to get basically our capsule trace by channel. So that's how that's going to work. So, and then you can go ahead and plug it into continue or to true and plug that in. It's not going to really work or do anything. So at the moment, you should be able to just do this, and you would be able to jump just fine. So yeah, as you can see, we're jumping just fine, but we're not going to be doing any traversals just yet, because we got to get those set up. So up here, what we're going to do is we're going to do a sequence, because there's a lot of things in sequence that we have to do before it'll do the traversal action. And let's go ahead and work on our step 1. So there's a lot of stuff in here. A lot of it's going to be local variables, because we're not going to be using them anywhere else. They just need to stay in this function. So our first step, let's go ahead and we're going to grab our actor location. So go ahead and right click and do get our actor location, because we want to check where our actor is placed at in the world in relative location or relative distance of like what we'll be traversing over. So then once you do that, go ahead and right click the return value and promote to local variable. And we're going to call that actor location, just like that. And just set it up top because we're going to be passing a lot of data through. So then the next one that we want to get is we want to right click in the space and do get actor forward vector, just like that. And same thing, we're going to promote that to local variable and we're going to call it actor forward vector, just like that. So basically what this is doing is just kind of like how you would kind of do the movement on a traditional like third-person template setup, where you would be using like the get right vector or get forward vector or whatever. This is getting like the owning actor of like this, you know, function or whatever, their forward vector. So basically when we move forward, we're getting that vector point, right? So we would be getting like somewhat from our velocity or something like that, somewhere in that where we're getting like the 500 or we're getting other specific parameters of the forward vector. So that's basically what we're doing, is getting whatever, we're just getting our vector going forward. So go ahead and plug these in, move that to the side for the moment. And then the next thing we're going to do is we're now going to get our capsule data, so our collision capsule, because what we're going to be doing eventually is we're going to be doing a lot of capsule traces by channels. So we need to be able to get all of this data ready for when we start doing all those traces in order to do the traversal action. So go ahead and grab your capsule component just like that, and then drag off of it. We're going to do get scaled capsule radius. So basically what we're doing is we're getting the radius that is scaled by the component scale. So when we look at our component capsule, all we're doing is essentially getting this is our capsule radius. So right now it's a 35, right? So if you were to actually make a capsule trace by channel, just like a brief one, you'll be able to see the radius is going to be similar to how it looks in here. And that's another thing, guys, I want to make note of, is that I'll be doing a lot of videos with the traversal action, but unfortunately I won't be able to do a lot of demonstration on what it's actually doing, because as we work through this, there's not really much to show, because that's basically all done as the end result when you set up the animations. However, I will show you how everything works debugging wise, so you get the gist, you know, in the later video or the last video of the traversal series on how it actually is supposed to go or how it's supposed to look. So now that you know where the capsule radius is coming from, or the scaled capsule radius, we can go ahead and move that up there. And then we're going to promote this to local variable, and we're going to call it the capsule radius. Okay, and then now that we got that, go ahead and connect that, move it over. And then the next one we're going to grab is we're going to do capsule component again, and this time we want to get the half height. So get scaled capsule half height, so at the top. So if I understand this correctly, we're getting this, which is, I think the half height is kind of misleading because it's not, I guess, not half of anything, but they're calling it that because I guess when you started out originally, it'll be half of kind of like what the, you know, the length of it would be. But honestly, you're just getting the full height of this from my understanding. So because we have this at 90, right? If I made it 80, that's what we're getting. If I made it 70, that's what we're getting. But since it's at 90, that's what we're essentially getting. Oops. So let's go back into here, and we're going to then promote this to a local variable, and we're going to call it a capsule half height, and put that up here, and then we're going to plug that in. So now we have 4 major very important variables that we'll be using later in the functionality of the traversal action. So essentially we're getting wherever our location is, we're getting what's in front of us, we're getting the radius of our component capsule, and we're getting the height of our component capsule because we'll be using these in the line traces. I know I keep reiterating it, but I'm just trying to drive the point through. So now comes the fun part where we're going to be setting up the get console variable int values and float values. So let's first set them up and I'll show you what needs to be done here. And I'm going to also put in the variables probably in the description, or I'll find a way to, what I'll probably end up doing is doing like a site where you can easily copy paste from, but for the moment, let's just go ahead and go through this. So we're going to right click and we're going to do get console variable int value. So what this is doing essentially is we're getting the console command variable. So as you'll see down here, we have console commands. The console commands in Unreal Engine 5 are very useful if you're trying to debug stuff, look at capsule traces. I'm pretty sure everybody's familiar with motion matching, especially since we're trying to copy the game animation sample project. And with motion matching, they have motion warping, or at least when there was YouTube videos speculating about what the game animation sample project would be, we would be using a thing called character trajectory, which would use console command values to be able to show like the trajectory lines of where we're moving and do predictions of where we're going next, right? So for this, what we're trying to do is we're trying to get one of those console command variables, but we're trying to get specific int values from it, right? So I'm pretty sure everybody's familiar with a debug level. So if we talk about line traces, right, or like even a capsule trace, there's things in it, you know, like this. So let me real quick grab a line trace by channel, just for example. You have this right here, right? The draw debug type. Because what we'll be doing is we'll be using this to set these levels for, you know, for one frame, for duration, for persistence, you know, stuff like that. And basically these are indexed of 0, 1, 2, and 3 to, you know, show our value, right? Or our debug type. So we're going to be setting a variable that is similar to that, or that will basically grab this and set like a variable toward it that we can use and call within here, within one place or one central location. So for the moment, before I show you all that, let's go ahead and plug that in, and let's go ahead and promote this to a local variable, and we're going to call it draw debug level. And we're going to keep it as an integer, and we're going to set that a little bit forward because what we're going to do is it's going to be kind of long with the naming. And then after that, we're going to get another console command variable. So to get console variable, what we're going to do is we're going to give it a float, because what we're going to use this for is to set the duration of the visibility of the draw debug types, like I was showing you earlier, like the none, duration for one frame, persistence, etc. And we're going to promote that to a local variable, and we're going to call that a draw debug duration, just like that. So now we essentially got that set up, and it's time to show you basically how to find the good stuff. So basically in your Unreal Engine projects, you can see that I have a lot of projects, but one in particular is the game animation sample project. So if you don't already have this, I recommend downloading it so that way you get the data that we're trying to get. So let's go. Well, once you have that installed, or if you already have it installed, you're going to go there, you're going to go into config, and we're going to look for the default engine.ini, and we're going to open that up. So I know you're going to see a lot of variables in here that, you know, if you've ever experienced modding games before, this should look pretty familiar, especially for what an ini file is. But what we're going to do is we're going to scroll all the way down, and we're going to grab these two sections. This one, not so much, but it's useful to have anyway because we don't already have it. So as you can see, like, let me open up the one that we're working on. So right now we're in the GASP tutorial that I've created. So if I go to content, or not content, if I go to config and then default engine.ini, As you can see with this version, I only come down to the Android file server runtime settings, which is right here, just above us. So we don't have these last two sections. However, our most important section is this, but I'm going to copy both of these anyway. So when it says data-driven console variable settings and the physics settings, you're going to go ahead and you're going to copy that, and you're going to then drop a couple spaces down in your main project's default engine.ini file, and you're going to paste it in there just like that. Once you've done that, you're going to then save it, and then I'm going to move well, let me actually explain what this is doing first. So as the best I can. So as you can see, we have a C variable that are bools. So we have like 1, 2, 3, 4, 5, 6 bools in here. We have an int value, a float value, another int value, and then a 7th bool value. So basically, this is determining whether, you know, we have, I guess our mesh has trajectory for my guess, because we have, it's a bool. Whatever our draw query is. I'm not sure what a lot of these do, but what we're looking for in particular is this right here and this right here. I'm pretty sure the others are useful, but I'm not sure where they're used yet, so I can't really give you a good explanation of what each of them do, but you can kind of get the gist of what they're calling for, because, you know, bool, int, float, stuff like that. So within our draw debug level, you'll see that we have default values of zeros, and our default bool is false. And then for our debug duration, you'll notice that we have a default float value of 1 second or 1 unit, right? So that's its default value. So let me move that over and then drop out of here. So now that we've added that, I should be able to get, because you'll notice that in the game animation sample project that we do need those two variables right here, the data-driven console variable for debug draw level and the duration. So let me open that back up. So let me see if I need to restart or not. So if I copy the level, yeah, it's not in there. So that's what I wanted to make sure of, guys. So once you do that, because I couldn't remember if that was the case or not, but once you do that, go ahead and close your project and, well, compile, save, and then close your project, and then reopen it, and then we can continue moving forward. So I'm going to do that now, and I'll see y'all when I load it back up. All right, guys, welcome back. I did, while I was waiting for this to load back up and other stuff, I did briefly look at data-driven console variables just so I can give y'all an explanation in this video. So basically, in simple terms, a data-driven console variable in Unreal Engine are ways to control and tweak various settings in your game dynamically without needing to hard code them. So think of them as special commands you can use to adjust the game parameters like on the fly. So like, you know, here's a simple breakdown. With console variables, these are settings that you can change while the game is running. They can control things like graphics quality, physics setting, or debug options. The data-driven part, this means that the variables can be set and modified based on data, such as configuration files or user input, rather than being fixed in the code. So by using data-driven console variables, you can easily test different settings and optimize your game without needing to recompile or restart it. So in our case, we had to restart just because we had to save all the stuff that we were just doing in order to pull them back up. So now if I go back here and I paste in the variable, you could see that we now get the traversal debug draw, right? So then if I go and remove this, you can see the other stuff that has come up, like the duration, the state machine, etc. But what we're looking for is the one I copied. So in the int variables, let me remove that. In the variable name here, we're going to copy our draw debug level and have that be set in here. So basically our int value, like we showed earlier, is 0 by default. So our debug level is going to start at 0. And then our next one is the debug draw duration. So go ahead and get that and copy it from here and paste it into the variable name here. So from here, you'll also notice that we have a 0 in here, but that's because that's what our parameter here, or our variable here, is set. Once this gets read, it's going to get that default value of 1 and pass it and set it into here for our duration. So that's what's going on there. So with that, we now have completed our first sequence event. And so what I'm going to do is I'm going to copy the comment here for y'all to also utilize, or to utilize with your code so you know what's going on now. So let me go ahead and move that, go back in. So here you go. So basically our step 1 is finally completed. So we cache some important values for later use in the function. So that is pretty much it, guys, for this video. I'm going to stop it right here. And in the next video, we are going to be looking at this behemoth that I got set up, where we look at our step 2.1, where we set up some channel tracing, or a capsule trace by channel. We get some ledge transforms. And here is where we're going to also look at migrating assets, because we will need this level block so you see how stuff works. So hopefully you do have the game animation sample downloaded. And in the next video, we're going to look at migrating that in there, and then going through this second part where we set up our capsule trace, we set up our debug, and checking if the traversal level block was found. So other than that, guys, it was fun. I'm excited to get into the next video, and hope to see y'all then. Take it easy. Bye.